I welcome you all to the perfect fusion of traditional and digital education system, Charvik Academia. I myself, Mahesh Patel from physics. My subject is physics. I'm going to tell you something, few concepts in the physics now. Okay, so let us start and learn few interesting concepts in physics. We are starting with the concept of centripetal force. Okay, what is centripetal force? Fine. Something, otherwise anything that revolves required a force to stay on a circumference. Listen me carefully what it says. Anything that revolves requires a force towards the center. See, towards the center we require force if we want to revolve on a circle. To revolve, anything that revolves, listen me carefully, anything that revolves requires a force towards the center. That is known as centripetal force. Centripetal force. For example, suppose there is a particle of mass m that is revolving over a circle of radius r, then this be a particle of mass m, the center, and this becomes actually the radius r. Now as it revolves, as it is just revolving over the circumference, it experiences a force towards the center. That force is known as centripetal force. See, that force is known as centripetal force. Actually, centripetal force binds the particle towards the center and allow it to revolve over the circle. See, the most important factor I should have said you is, see, a force, centripetal force. Listen me carefully, we are discussing about the centripetal force. Okay, a centripetal force binds the particle towards the center and allows it to revolve. It means if you want to revolve on any circle, it requires a force, and that force is centripetal force. Centripetal force acts towards the center. Now the most important factor, how do we calculate that centripetal force? Okay, so there is a single formula to calculate the centripetal force, and that formula is mv squared upon r. This formula gives us the magnitude or the value of the force which is acting over you while you are revolving over the circumference of the circle, right? This is the formula. This is the factor that is giving us the magnitude or the value of the force that keeps us revolving over the circle, or a required amount of force that is acting towards the center to revolve over it, right? So this is what about the centripetal force. Now listen me carefully, there is another part of this formula. See, otherwise this discussion, there is another force we know as a centripetal force, that is we already have discussed it here, that is a centripetal force. But look at that formula closely. See, the mass of the particle which is revolving over the circle, very easy we say it's a constant value. The radius of the circle over which you are revolving is also a constant value, means mass and radius are going to be the constant factor. The thing that varies, the thing that changes is velocity. It does mean that F depends on velocity square. F is proportional to velocity square, right? So there is another factor of the same force, that is what I am writing here. See, if we say F is equal to mv square upon r, mass and radius are being a constant factor, so they are not going to affect you or the particle that is revolving over the circle, right? Fine. But the velocity that plays an important role. See, there is another force that is known as centrifugal force. See, this is a centrifugal force which acts radially outward, it throws you from the circumference of the center. The force is acting radially outward, right? Now, who will decide and how do we decide that which is centripetal force and which is centrifugal force? Remember, see, centripetal keeps you towards the center, that force keeps you towards the center, binds you towards the center, and that throws outside the center, right? Okay, under the effect of centrifugal force, you will be thrown out of the circle. Right? That is centrifugal force. But listen carefully. See, who will decide? Because a single formula works for both the case. Either you are binded to the center or you are thrown out of the center, but two factors are constant. Now, the most important factor comes here. See, if there is a value of velocity, see, there is a fixed value, there is a certain, you can say certain value of velocity which produces centrifugal force, centripetal force towards the center, right? There is a certain value of velocity. Up to that value, you are experiencing a centripetal force which is towards the center. Listen me carefully. Up to that certain value of velocity, you are experiencing a centripetal force. If you exceed the value of velocity, the force will be converted into, listen me, the force will be converted into centrifugal force. It does mean that the certain value, up to the certain value, your force will be centripetal. If you exceed the value of velocity, then it will be converted into centrifugal force, and with that velocity you will be thrown out. Let's take a certain example that is very easy to understand. I need some space, so I'm just clearing a few area out. Okay, so just taking these two lines out, right? See. Fine. Now let's take the better example that you must have felt in your day-to-day life. Suppose you are actually going from one city to another. You must have passed by the highways. So you must have seen such things that suppose there is a straight line and then the curvature comes, okay, over the road. See, this is the road, right? Now this is where the curvature started. You can just draw the circle. Imaginary circle is right there. This is an imaginary circle over which the particle is expected to revolve. Especially your vehicle is considered a particle that is revolving over the circle, right? And this is what the center of the circle is. Fine. Now when your vehicle is just moving on the road, okay, it is a straight line motion. When it comes over this boundary, when it just enters into this region, your vehicle and the passengers sitting inside is experiencing a force towards the center. That force is centripetal force, which keeps the particle towards the center. Okay, the mass m and the radius of the circle is considered. Now, under the effect of that centripetal force, you complete the entire curvature successfully, because on every point of the curvature, until you go out of the curvature, until you go out of the curve, this keeps on acting on you. Like this is a centripetal force, these are the directions towards the center which allows you to take the turn. See, listen me carefully. The vehicle takes a turn under the effect of centripetal force, okay, and that is written right here. See, there is a certain value of velocity you must have seen on a triangle board right here. See, if it is written so that 40 km per hour, it does mean that you are allowed to move over this road with 40 km per hour only while taking a turn. Because this is a certain value of velocity that is required to create the centripetal force. Okay, there is a centripetal force, and that centripetal force will be created with 40 km per hour only. If you exceed the value of 40 km and if you have started moving with 45 km per hour, then believe me, my friends, if you exceed the value of required, otherwise certain value of velocity, your force which was centripetal, now exceeding the value of velocity will be converted into centrifugal. In this case, your vehicle will start experiencing a force on a radially outward sea, because centrifugal force throws you out of the circle, means your vehicle will start moving, otherwise experiencing a force on an outward direction. Therefore, there are chances for your vehicle to be thrown out of the circle and move into the tangential direction. So whenever there is a signboard just says something 40 km per hour, just believe me, it is the velocity that would have created the centripetal force. You need to move this velocity because your vehicle requires a centripetal force, because you want to stay over the road, over the circumference, and complete the turn. In completing the turn, you need a 40 km per hour, which will help you out in creating a centripetal force, will bind you toward the center, and successfully you will take a turn. But if you just try to move, exceed, otherwise just go beyond the value of the assigned velocity, then 45 km might be the fastest value, otherwise the faster value than required. Then your force that was centripetal, which was keeping you towards the center, will throw you out, because now your force has become centrifugal. So in such cases, you might experience, otherwise you might undergo the larger accidents. So it is not advisable to go beyond the value of the signboard, otherwise the velocity that is written right here. So there was an interesting example I have written here, okay, that describes the basic physics, otherwise the concept of physics in day-to-day life, right? So there are so many otherwise very interesting examples I have with you, not only for the centrifugal force or centripetal force. You can see, otherwise I can help you out in observing the physics in day-to-day life. Every part of the physics I can bring the examples from day-to-day life and will show you. See that here the physics is. In every move you are making in a day-to-day life, I will make you see where the physics is, right? So to learn the basics of physics or the interesting examples of the physics, you just have to visit to us as soon as possible. Please come to us, to the Charvik Academia. I just welcome everyone from the family of Charvik Academia. Thank you for listening me carefully. Have a nice day.
My dear students, hope you all have enjoyed the understanding of most important concept of these subjects in this demo lectures. Don't be sad. This is not where we have finished. This was just a drop from the ocean of our academia. Students, our experts have designed a few exclusive packages just for you to provide not only a full series of lecture but also the chapter topic wise test series with deep analysis, like precise timing you spend on every question you attempted. Listen carefully. Precise timing you spend on every question you attempted. This is the most important factor for your exam timing. Same, live doubt session is also there, live lectures is also there, and much more in our packages. So I explain you all our 5 packages. You just select any one you like. So our first plan is bronze plan. This plan includes the recording of video lectures series in HD quality. So you get precise recording. Our second plan is silver plan. Here, along with recorded video lecture series, as I explained, you get chapter topic wise test series with in-depth analysis, right student? Our third plan is gold plan. This plan covers the benefits of both bronze and silver plan. In addition, you will get monthly live doubt sessions as per the time slot scheduled, right? Fourth one is, dear students, platinum plan. This plan includes weekly live doubt solving sessions as per the time slot scheduled and separate video for the topic which were found to be weak during the test series analysis, right? This is the most important for you. In addition, the benefits of the bronze, silver and gold plan remain. And our last diamond plan. This plan includes live lectures with doubt solving sessions and chapter topic wise test series. The video recording of the same live lecture will also be available throughout your academic year. Listen carefully. The video recording of the same live lectures will also be available throughout your academic year in your account, right? So dear students, these are our plans. You can start with the bronze plan and upgrade whenever you want. Thank you students. I hope you join the Intedsys family as early as possible.